Hello, my name is Addy bin Haris. My matrix number is 07DEM23F1007, and our group will be presenting about the end of chapter presentation, chapter 1, PIC programming in C.
Hi, my name is Hazelley and my matrix number is 07DEM23F1017, and I'm the edit partners for this presentation.
Many electronic systems use LED lights to show activity or status. One common effect is a back and forth running light, where LEDs turn on in order and then reverse, like in scanners or displays. In this project, we use a PIC microcontroller and the MPLAB IDE with C programming to create this effect. 3 LEDs are connected to pins RC0, RC1, and RC2. First, the LEDs turn on one by one from RC0 to RC2 in forward 5 times. Then, they turn on to RC2 back to RC0 in reverse 5 times. After that, the sequence starts again and keeps repeating. And if else statement is used to decide whether the LEDs run forward or backward. A 0.5 second delay is added between each step. The LED changes can be clearly seen. This project helps us understand how to control LEDs, use delays, and write simple logic using a microcontroller. This program starts with #include xc.h, which allows the PIC 16F877A microcontroller to understand all the register names and delay functions used in the code. The #pragma config lines are used to set up the basic system configuration. The oscillator is set to high speed with FOSC equals to HS. The watchdog timer is turned off, the power up timer is turned on, and brownout reset is enabled to protect the microcontroller if voltage drops. Low voltage programming and code protection are turned off so the program can run normally. In this program, WRT equals to off means the memory write protection is turned off. So in the program, in the microcontroller can be changed or updated anytime. The CP equals to off means code protection is also turned off, which allows the program to be read or copied if needed. This setting makes it easier to test and modify the code during development. However, in a real product, this can be turned on to protect the program from being copied or changed by others. Next, _xtal_FREQ is defined as 4 MHz so that the delay function _delay_ms can work with the correct timing. The constant forward_repeat and delay_ms are used to control how many times the LEDs will blink and how long each LED stays on. The program then sets up 2 main functions, init_ports to prepare the output pins and run_sequence to control how the LEDs light up. In the main function, the program first calls init_ports to set port C as output using 3C equals to 0 multiply 0, 0. And to make sure all LEDs are off using port C equals 0 to multiply 0, 0. Then, inside a while loop, the function run_sequence keeps running again and again so the LED pattern continues without stopping.
So I'm going to move next explanation for this coding, which is the run sequence function. The run sequence function is control the LED movement. It uses as a variable called forward to decide the direction of the LED pattern. When forward equals to 1, the LEDs turn on one by one in the forward direction, starting from RC0, then RC1, and then RC2. Each LED lights up for 500 milliseconds using _delay_ms 500, which is equal to 0.5 second. This forward sequence repeats 5 times. After that, the direction change to reverse. When in reverse mode, forward equal to 0 in bracket, the LEDs blink in the opposite order, starting from RC2, then RC1, and finally RC0, also with a 500 millisecond delay, which is 0.5 second. After five repeats, the direction change back to forward, and the cycle continue forever. Before each new sequence, all LEDs are turned off with port C, that equal to 0 times 0, 0, to make the transition smooth. So if the if and else statement are important because they control wherever the LEDs move forward or backward. This meets the requirement of using an if-else condition in this program. The delay function helps control the timing so that the LEDs blink clearly one after another. Overall, this program lights up 3 LEDs in a running pattern. The LEDs turn on in one direction for 5 rounds, then in the opposite direction for the another 5 rounds, and keep repeating endlessly. It shows how to control LED outputs, use timing delay, and apply logic condition in PIC microcontroller programming. That's all for the coding solution. So I will move to my present part, which is conclusion. So in conclusion, through this project, students gain a clear understanding of how to control hardware components using PIC, microcontroller, and C programming. Learning how to configure digital output pins and control LEDs using logical structure such as if-else statement. The implementation of delays helps students manage timing between LED sequence, while loops and counter are used to repeat the forward and reverse pattern. Additionally, the student become familiar with using the MPLab ID to write, compile, and upload embedded C code. So overall, this project strengthen the student's skill in programming, hardware interfacing, and logical thinking, which are essential for future work in embedded system and microcontroller-based application. So that's all for our presentation for this end of this chapter. Thank you.